Hello everyone, in this tutorial video, I'd like to explain the method of partial fractions when you integrate functions, also known as fraction decomposition. Some rational functions can be simply evaluated with the substitution rule, if you know the numerator is the derivative of the denominator, like this integral. But unfortunately, many rational expressions are more complicated than this, and do not have the numerator as a direct derivative of the denominator. We would have to figure out in a different way. For example, using this integral as an example, we would first factor the denominator, and then state it as two fractions, a over factor 1 plus b over factor 2, where a and b are unknowns. We get these in terms of the original denominator by using the method of the least common denominator. So we multiply a by b's denominator and b by a's denominator. We see because we now have the identical denominator on both sides, we can cancel it out. And see that at specific x values, you can get a or b by themselves and get an exact value for them. For example, at x equals -2, -2 plus 2 equals 0, so a times 0 goes away, and you can get b by itself, which will be -1. Similarly, at x equals 3, b will go away, and you can get an exact value for a, which will be 4. We then substitute in these exact values for a and b, divide the integral into individual integrals of the a fraction and b fraction, and then finally use the substitution rule, so that it simplifies to 1 over u for each integral, and we know the integral of 1 over something is ln of absolute value of something. In conclusion, that is our answer for the integral. Now that we have seen how partial fractions work, we can move on to integrals involving roots, and how you can do a more tricky type of substitution with them, just like you can do more tricky types of substitution in terms of degrees, in order to simplify some integrals. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.